Okay, I wanted to make a quick video to discuss a little bit more about constructors as they relate to inheritance. And so for this quick example, I've got this shape class, okay? And the shape has one attribute, a color. It's got an empty argument constructor, and then it has a get color and a set color, and then a toString method. So basically there's not a whole lot here to this shape. Okay, you'll notice that the toString method prints out that it's a generic shape with a certain color. All right, now I've created a circle class over here that actually extends shape, and it adds an attribute radius. So now the circle, because it extends shape, has both a color that it inherited from shape, and it has a radius that's defined right here in circle. So it's got an empty argument constructor, it's got a getter, it's got a setter, and it has a toString method, which you'll notice in this case, instead of just printing out generic shape, it says that it's a circle with a radius, and it has a color, and it calls the getColor method from the shape superclass. So remember, getColor, you'll see, isn't defined anywhere here in circle, but it is defined right here in shape, is getColor. Okay? Now, the thing that I wanted to point out was, in both of these cases, circle has an empty argument constructor and shape has an empty argument constructor. Now, as I stated in a previous video, when you actually create an instance of circle, what you are first doing is you are first basically creating an instance of shape. That's what's happening behind the scenes in memory. And so this shape constructor is going to be called implicitly. And then afterwards, the circle object gets instantiated. And so in this video, I wanted to point out what would happen if here in shape, I said, you know what, instead of having an empty argument constructor, I am going to accept a string C, and now I'm going to make color equal to C. Okay, so now shape only has this one constructor, and it accepts an argument. So it doesn't have any empty argument constructors anymore. It just has this one constructor, okay? Well, if I go ahead and compile this, shape works just fine. But if I go over here into circle, you'll notice that if I try and compile this, okay, now I get an error. And it says that shape in class shape cannot be applied. So basically the reason why that's happening is because, again, because this circle class extends shape, when I try to instantiate a circle, the first thing that it's going to do is it's going to go try and create a shape object. And in this case, it's looking for either a default constructor, which accepts no arguments, or an empty argument constructor, which accepts no arguments. Well, I've modified my shape class where there isn't an empty argument constructor. So now the compiler is sort of confused and it doesn't know what to do. So you might think, oh, okay, well, I can just correct this, right? I can make my constructor have the same argument list. So if I said string C, and then I did something like, set color C, then that would solve the problem. But in fact, you'll see that, nope, I get the exact same error, okay? Because this constructor right here is looking to make a call implicitly to an empty argument constructor in the superclass, and that does not exist. Okay? So I could, over here in my superclass, I could create an empty argument constructor, and that would make my compiler error disappear. Okay? Or what I could do is I could say, you know what, I'm going to just go ahead and explicitly call the superclass constructor using super. So I'll do super C like this. And now, because I've made this call to super, this is going to say, the compiler is going to say, okay, now I know what to do. Now I'm not looking for any empty argument constructors. And you'll see that that compiles just fine. Okay? So that's just another example of how you might use super and the relationship between constructors in superclasses and subclasses.